we will discuss an index notation which also is related to Einstein's summation convention in this video. These two notations and the summation convention is very important in handling of tensor quantities. So, we saw while discussing the introduction to tensor that electrical conductivity was written as a tensor, and the 9 components of the electrical conductivity sigma 1 1 to sigma 3 3 relates the 3 component of the current density vector, 3 components of the current density vector to 3 components of the electric field vector. These are the 3 components of the electric field vector. So, each component of the current density is related to the 3 components of the electric field, and that gives 3 component of the conductivity tensor. These quantities are the conductivity tensor. Now, we can write this equation in the summation convention using sigma, as you all know. So, I can write the first equation as, so I can write this as sigma 1 I E I going from 1 to 3. Similarly, J 2 is sigma 2 I E I going from 1 to 3, and J 3 sigma 3 I E I going from 1 to 3. So, this notation is little bit more compact than writing them out in full. Summation saves us writing all the terms. Now, Einstein observed and introduced a new notation for further simplifying in this. He look at the right hand side term, you find that the summation is over I, and I is the subscript which is repeating in the right hand side term. One is a fixed term, fixed index, where I is a repeating index, and the summation is on the repeating index. So, in all 3 cases the summation is over the repeating index. So, the simplification which Einstein introduced was simply to drop the summation sign and write it as sigma 1 I E I, and assume that whenever the index is repeated, summation is implied. So, it becomes even easier to write. So, this is what is Einstein's summation convention. Sometimes humorously referred to as Einstein's greatest contribution. So, it makes writing the equations easier, and further all the three equations, if you see, have the same form. J 1 is sigma 1 I E I, J 2 is sigma 2 I E I, and J 3 is sigma 3 I E I. So, the three equations can jointly be written as using another index J k is equal to sigma k I E I, where both I and j, I and k are now running from 1 to 3. But since on the right hand side I is repeated, summation is only over I, k we do not do the summation. But since as k varies from 1 to 3, we reproduce the three equations J 1, J 2 and J 3. So, sometimes because you can also see an interesting thing, that since summation is over the repeated index, it does not matter what repeated index I use. So, even if I write this as, let us say K L E L, where I use another index L, it does not make any difference in the equation, because I going from 1 to 3 gives us the same 3 terms on right hand side as L going from 1 to 3. So, L being repeated is again indicating summation over L, and the variation of L is from 1 to 3. So, you get the same expression. So, that is why these indices, the repeated indices, are sometimes called dummy index. You can replace them by any letter. But k is not dummy, and I can't, if I make k to some other subscript, then the equation will become inconsistent, because k appears on the left hand side, but not on the right hand side. So, this is the fixed index, and same fixed index should appear in the equation on both left and right hand side, but it does not matter what dummy index appears on the right hand side of this equation, it can be replaced by any other subscript. Thank you very much.